Hello everyone, I'm Mishavi. Currently, I'm pursuing my degree in Sri Venkateswara College of Engineering, and my topic is on energy density in terms of Einstein's coefficient. Let's derive an expression for the energy density in terms of Einstein's coefficient. The rate of induced absorption is depending on the number of the electrons in the ground state and also depends on the energy density of the incident photon. The rate of induced absorption is directly proportional to the electrons in the ground state, and the rate of induced absorption is directly proportional to the energy density of the incident photon. Therefore, the rate of induced absorption is directly proportional to the n1 e mu. That is, the rate of absorption is equal to the B12 n1 e mu. Here, B12 is represented as the Einstein coefficient of the induced absorption constant. Spontaneous emission. During this emission, atom in an excited state will return to its ground state by emitting a photon of energy E mu without any external agency. That means this process is not depending on the energy density of the incident photon and depends only on the number of electrons in the excited state N2. The rate of spontaneous emission is directly proportional to the N2. That is, the rate of spontaneous emission is equal to A21 N2, where A21 is represented as the Einstein's coefficient of the spontaneous emission constant. Stimulated emission. During this emission, all the electrons in the excited state are transferred to the metastable state. When the light passes through the atom, then the electron returns to the ground state by emitting a stimulated photon. Here, the rate of stimulated emission is depending on the number of electrons in the metastable state N2 and also depends on the energy density of the incident photon. Therefore, the rate of stimulated emission is directly proportional to the N2 E mu. That is, the rate of stimulated emission is equal to B21 into E mu, where B21 represents the Einstein coefficient of the stimulated emission constant. So at the thermal equilibrium, by conservation of energy, we can write rate of induced absorption is equal to rate of spontaneous emission plus rate of stimulated emission. B12 N1 E mu is equal to A21 N2 plus B21 N2 E mu. Taking B21 N2 E mu to left side, that is B12 N1 E mu minus B21 N2 E mu is equal to A21 N2. Taking E mu common in LHS, E mu is equal to A21 N2 by B12 N1 minus B21 N2. Taking B21 N2 common in denominator, E mu is equal to A21 N2 whole divided by B21 N2 into B12 N1 by B21 N2 minus 1. That is also equal A21 by B21 into B12 N1 by B21 N2 minus 1. Here N2 and N2 will get cancelled and it is considered as an equation 4. Now from the Boltzmann law of ratios of the population densities N1 and N2 in the ground state E1 and excited state E2 respectively is given by N1 by N2 is equal to e power h mu by kt. Considering it as equation 5 and substituting equation 5 in 4, E mu is equal to A21 whole divided by B21 into B12 by B21 e power h mu by kt minus 1, considering it as equation 6. But from the thermal equilibrium formula by Planck's law is equal to E mu is equal to 8 by hv cube whole divided by c cube into 1 by e power h mu by kt minus 1, considering it as equation 7. From equation 6 and 7, A21 by B21 is equal to 8 by hv cube by c cube and B12 by B21 is equal to 1. Therefore, B12 is equal to B21, which implies that the probability of the induced absorption is equal to the that of stimulated emission. The energy density at thermal equilibrium is equal to the E mu is equal to A by B into e power h mu by kt minus 1. This is an equation for the energy density in terms of Einstein's coefficient. But here A by B is equal to 8 by h mu cube by c cube, which implies A by B is directly proportional to the mu cube. That means the rate of spontaneous emission is directly proportional to the energy density of the incident photon, and the rate of stimulated emission is inversely proportional to the energy density of incident photon. After observing all these things, finally Einstein came to the conclusion that is thermal equilibrium for two energy levels. We cannot produce laser light due to the stimulated emission is too less in this situation.